So part A tells us to solve for the magnetic flux through the loop as a function of time. So magnetic flux is equal to B times A, but in this case B is at an angle to the area, so you have to multiply by cosine of 60 degrees because cosine is what gives you this portion. And so that is equal to, and then B is equal, it says is equal to 4 times 1 minus 0.2 t. And then times area, which is just pi times 0.1 squared. Then times cosine of 60 degrees, which is just 1/2. So when you simplify that, you get 0.063 times 1 minus 0.2 t. So according to the equation we found in part A, the graph in part B should be a linear one, which starts at 0.063, because when you plug in 0 for t, you get 0.063. And then it's decreasing by a slope of negative 0.2, so by the time it reaches 5, it should go to 0. And then by the time it reaches 10, since it's the same slope, it should be at negative 0.063. Part C says to solve for the induced EMF in the loop. So induced EMF is equal to negative change in flux over with relation to time, which is equal to negative derivative with respect to time of the equation we got from part A. So 0.063 times 1 minus 0.2 t. When we take the derivative of that, we get negative 0.063 times negative 0.2, which is equal to 0.013 volts. So part D1 says to solve for the induced current in the loop, and from part C we know that the induced EMF is 0.013, which is equal to V, and current is equal to V over R. And it says that the resistance of the loop is 50 ohms, so 0.013 over 50 gives us 0.00026 amperes. And that's the current in the loop. And for D2 it just says to show the direction of the induced current in the loop. And we know that the equation of flux is 0.063 times 1 minus 0.2 t. So the slope is negative, and so we know that the amount of magnetic field is decreasing. So the loop would want to keep the magnetic field the way it is. So it would want more magnetic field this way. And to induce that magnetic field this way, the loop would need a current going counterclockwise, because according to the right-hand rule, that is the current that induces the magnetic field upwards. So part E says to solve for the energy dissipated in the loop from t equals 0 to t equals 4 seconds. So we know that power is equal to I times V, and power is also equal to dE over dt. And since it's not very small increments, we can assume that we can just use this form of the equation. Delta E over delta T is equal to IV. And so voltage is 0.013 as from part C, and then current is 0.00026, and that times delta T is going to give us delta E. So delta T is 4 minus 0, and that gives us 1.3 times 10 to the negative 5th joules.